Hi students, welcome back to that is your channel Physics by Imagination. Dear students, in the previous class we had understood about that is alternating current. So let us understand in this class about electromagnetic waves. Dear students, what are electromagnetic waves? These are nothing but we know that what are waves? They are a kind of disturbance which produces in any other medium. So electromagnetic waves means what? These are the waves. They will be disturbed in the medium and they are oscillating with two fields, that is electric field and magnetic field, and they are oscillating perpendicular to each other. The angle between this electric waves and magnetic wave is about 90 degree. So this is called electromagnetic waves, means the waves which are oscillating of the charge and produces, if charge is going to be oscillated, then it is going to produce electric wave as well as magnetic wave, and these waves combinedly we can call as electromagnetic waves. After understanding the definition of electromagnetic waves, let us understand that what are the properties of electromagnetic waves. So the first property, speed of these electromagnetic waves. Dear students, we know that the speed of light given by equation c is equal to 1 over square root of mu naught epsilon naught, where mu naught is called, that is 4 pi into 10 to the power of minus 7. This is epsilon naught, we know that is 8.85 into 10 to the power of minus 12 coulomb per Newton meter square. If I substitute, which gets 2.99 into 10 to the power of 8 meter per second. So what does it mean? I am telling you that these waves can move with the speed of light. That is the first property. Second property, there are non-mechanical waves. So what are non-mechanical waves? The waves which do not depend upon any other medium are called non-mechanical waves. They can move in the vacuum too. Third point, dear students, it is going to carry energy and momentum. So we know that the great equation, that is mass energy relation, that is called E is equal to mc square. Now I would like to get the expression of momentum of this wave. So this can be done as, that is m into c into c. We know that the product of mass and velocity is nothing but momentum, which becomes p into c is equal to e, and p is equal to e divided by c. Very important on CT and neet, that is momentum is equal to energy per speed of light. Okay, so after this is the expression for momentum. And also let us find that is energy flux density. So what is energy flux density? This amount of energy per unit area per unit time. So which is given by equation fourth one, energy flux density of these waves are given by, that is pi is equal to energy per unit area per unit time. Very important, which is used often, they ask in the CT exams, dear students, that is E divided by A into T, energy per unit area per unit time. It is called energy flux density. So it becomes joule per meter, that is second. This is the unit of this energy flux density. So now after understanding this, let us come to the fifth point. So what is fifth point? How can we give the relationship between this electric field as well as magnetic field? We know that when the charge is at motion, it is going to produce both electric field as well as magnetic wave. Okay, magnetic field and electric field. So that is, we know that is given by equation BQV is equal to, this is magnetic force. We know that electric force is equal to EQ. So QQ cancelled, then V is equal to E divided by V. This is E called electric field, B is called magnetic field. This is called velocity of the charged particles, or you can call that electric, that is velocity of the electromagnetic waves. Very important, this formula also. Often they ask it in the CT. They'll give electric field and magnetic field. They'll ask to calculate velocity, or sometimes they'll give velocity value and magnetic field. You will ask to calculate electric field. Please note down. So after understanding about these electromagnetic waves, let us come to the point that is electromagnetic spectrum. Dear students, what is electromagnetic spectrum? So, after understanding electromagnetic spectrum means, in electromagnetic waves, we can find different waves like X-rays, gamma rays. Okay, let us understand it short period of time. So, I have made a code. Electromagnetic spectrum means what? The arrangement of different radiations. These are the different radiations according to their frequencies or wavelength is called electromagnetic spectrum. What is electromagnetic spectrum? The arrangement of different electromagnetic waves or radiations according to their wavelength or according to their frequency, according to increasing or decreasing order, that is called electromagnetic spectrum. Spectrum means a group of different radiations. Now, code is very simple, children. Army uses, remember, army uses weapons of X-rays and gamma rays. Very easy to remember. Army uses weapons of X-rays and gamma rays. I mean, they are using nuclear radiations. This is the code to remember different radiations. Army uses different, that is, weapons of X-rays and gamma rays. They are using nuclear energy. So now come to the point. R stands for radio waves, M means microwaves, I means infrared radiations, U means ultraviolet radiations, V means, that is, visible radiations, X means X-rays, G means gamma rays. So let us understand their frequency. We know that this is wavelength, the distance between the wave. Dear students, your longest wavelength means radio waves, smallest wavelength means gamma radiations. So we can use, that is, remember the first beginning, you should remember 325, that is plus 3 minus 2 minus 5. This is the frequency, that is wavelength of radio waves, microwaves, infrared radiations. This is approximately, you can use in the calculation 2. After that, just come to the, remember, 2 table. 2 3 is 6, that is 2 times of minus 3, 2 times of minus 4, 2 times of minus 5, 2 times of minus 6. Here 325, remember, that is code. And after that 2 3 is 6, that is minus 6, 2 of minus 4 minus 8, 2 of minus 5 minus 10, 2 of minus 6 minus 12. So this is about wavelength of these different radiations of, that is, from radio waves to gamma radiations. And we know that fundamental relation, that is V is equal to F into lambda. And here I am going to consider speed of light. So speed of light is equal to, that is, F into lambda. I know lambda, I want to find frequency. Frequency is equal to C divided by lambda. So C means 3 into 10 to the power of 8. Lambda value, if you go on substitute. For an example, I have understood these values. If you understand this, it's like piece of cake to find the values of the frequencies. Now 10 to the power of 3 is there. If I put 10 to the power of 3, it goes to 10 to the power of minus 3, that is 8 minus 3, 10 to the power of 5. This is nearly 1 lakh hertz. Similarly, minus 2, if it goes to numerator, 10 to the power of 10, 10 to the power of 13, 10 to the power of 14, 10 to the power of 16, 10 to the power of 18. Last, 10 to the power of minus 12 is there in the wavelength. If it goes to numerator, 10 to the power of 12 into 10 to the power of 8, it becomes 10 to the power of 20 hertz. So this is all about different wavelength and frequency of this electromagnetic spectrum. So last but not least, also apart from this, he is going to ask uses. Let us understand very soon. So first one, radio waves, as the name itself telling, used in radio, television, communication process, we are using this radio waves. Over. Next, microwave radiations, which is used in the micro oven, okay, like heat radiations, and we are using in the radar system, and we are using in the tele-long communication. For example, we are using geostationary satellites. There we can use this microwaves. So after understanding this, come to the point, infrared radiations. So infra means very, very important. The most often they asked, which is used in, that is, long distance photography. if I want to capture image at a far distance, the long distance photography you are using, and also treatment of tumor and cure the dislocation of the nerves, I mean fracture of nerves, there we are using this infrared radiations, and also these radiations are used in that is like cleaning purpose. Okay, so we are using that is sterilization, also we are using this infrared radiations. These are, again I am telling once again, long distance photography to cure tumor, to fracture and cure the treatment of tumor. Again we are using in the treatment of any fracture happen in the body, to cure the fracture in the body. This is all about infrared radiation uses. After understanding this, come to the point ultraviolet radiations. You know ultraviolet radiations which is filtered by ozone layer. Now here the first point is we will get vitamin D. Second point, from this it is used in that is sterilization of surgical instruments. Again we are using to find the food adulteration, like mixing of any components in the food, that can be identified by using these ultraviolet radiations. Next, visible radiations. We are all seeing the things because of visible radiations. They have wavelength 10 to the power of minus 18, minus 8 meter, and frequency 10 to the power of 16 hertz. And also used in the photosynthesis. Plants are going to use this visible light to prepare the food. And also we can use in the photocells to convert light energy into electrical energy. After that, X-rays, you know, any bone fractures happened, to scan the body, to find the foreign bodies in our body. And also it is used in the study of molecules, treatment of skin cancers. This is about X-rays. Okay, last but not least, gamma rays. These are very dangerous radiation, children. That is, they have 10 to the power of 20 hertz. Imagine in 1 second they are going to oscillate 10 to the power of 20 times. Highest frequency, you know that number of oscillation per second is called frequency, and they are having lowest wavelength. In exam often they'll ask which is having highest frequency, means gamma radiations, lowest wavelength means gamma radiations, highest wavelength means radio waves, and lowest wavelength means that is gamma radiations. You should remember. So this is all about electromagnetic waves. I think you understood, children. If you understand this video, please like it, share and subscribe. Thank you.